Hello, Algebra 2. Tonight's topic is Unit 8, Day 3, or 8.3. And we're going to be reviewing regression. We have two new topics to look at, two new functions that could have regression equations. Also, at the end of the video, I'll have a few questions to help you review for the quiz next class. So, essential question for the notes is, can I use my knowledge of functions to determine which type of function would best fit the data given to me? Now, we've been graphing these three new ones a little bit, but not too much. So exponential growth, exponential decay, and logarithmic. The ones we know really well are linear and quadratic, and we're pretty good with cubic now. But what I want you to do is take a look at these 6 graphs here. Each of them are different, and they'll match up to 6 of these functions. So I want you to pause the video a minute and determine which type of function would best meet the scatter plot. So if you think this one is a particular function, you'll write it here, and so on. So go ahead and pause the video and try that, and then bring it back. Okay, it was probably easiest to think about these three as you're looking at all the new ones. First, it was pretty obvious to see that this one was linear. That's our best known function. We've been talking about that since 7th and 8th grade math plus algebra. And then here's our quadratic. That one we learned in Algebra 1, and we've really been talking a lot about that quadratic. It would have a negative a, right, because the parabola is going down. Here is our cubic, where we have odd end behavior and 2 turning points. That's our cubic function. And then, so we're down to the 3 new ones. And remember, the difference between exponential and logarithmic is the way the asymptotes are. So here we have a horizontal asymptote. See how it evens out here at 0. It flattens out there. Here we have another horizontal asymptote. See how it's flattening out here. And our logarithmic has an asymptote here, a vertical asymptote. So our logarithmic would have a vertical asymptote and slowly grow, where exponential growth has a horizontal asymptote and grows pretty fast. That's why we talk about exponential growth. Our last one is exponential decay, and that's where it declines quickly. And they talk about that with depreciation, with cars or other new things that you buy. Okay, let's bring back some knowledge about how we do regression. Remember, when we're given statistics and data, we're going to use our calculator to help us. And remember, we looked at the correlation coefficient and the coefficient of determination. Please add this wording. The only one that's on there is the correlation of coefficient. And the differences are, correlation coefficient is the R, and the R squared is our coefficient of determination. And they are a little bit different in how they how they determine what's the best equation. But for our purposes, the thing you need to realize about these two, the R and R squared, is that the closer that R squared is to 1, or the absolute value of R is to 1, the closest it is to 1, the better the data fits the equation it is given. So for R and R squared, the closer it is to 1, the better the prediction of the equation will give you. So it's just showing you how strong your equation is. Okay. right, so let's look at our first example here and think about what it's saying first. And it says the data to the left shows the cooling temperatures of a freshly brewed cup of coffee after it's poured from the brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit, and it wants us to find the exponential regression model equation that represents this data. So in this example, we don't have to compare different functions. They tell us which one to find. But I do want you to review that in your calculator, how to look at the graph and make sure you see that it looks like an exponential. So the first thing I want you to do is remember to go to Stat. So when you hit the Stat button, this comes up and you want to hit Edit to enter your data. Now if you have old data in here, you want to clear that out. So you go up to the L1 and L2 and hit Clear and Enter to get rid of the old data. And you also want to clear out any functions you might have been graphing before. So go to your y equals and clear out any functions that you have here. Then you want to hit Stat and Edit again. And then you're going to put the independent data in L1. So in this case, our independent data is the time. The time is going to keep ticking along, and depending on how much time you have, will be how cool the coffee will get. So this will be our L1, our X data will be our time. And our temperature will be in L2, our Y, our dependent variable. So go ahead and pause the video and input that. Make sure you check it and then bring it back. Okay, so after you inputted the data, then you're going to run the regression model they said. And before we did that, in case they didn't tell you which one, remember to see the graph, you hit second Y equals, and then enter to turn on the stat plot, and then zoom number 9 for zoom stat to see what the graph looks like. And that does look like exponential decay. So let's see what the equation is, and we'll hit Stat, over to Calculate, and for exponential decay or growth, you're going to hit number 0 or it would be 10, but 0 for exponential regression. And remember, you have to hit that twice. So there's our equation. Remember, you plug in this number in for A, this for B, and then here's your R squared. So go ahead and take a minute and write in that with your equation. Okay, so you should have written in this value in for A and this value in for B. And it's a good habit to use more decimal places in this function than we might have in the past. So I recommend using 3 decimal places, the thousandth place. It's just because of the way it is, where our x is, it just makes our equation more accurate. So you should have written y equals 171.462 times 0.988 to the x power. So only the 0.988 is to the x power. Our r squared value is 0.97014. Now the question asks, is the equation a good fit? And remember how we looked at that r squared. We talked about how it should be closest to 1, which this is. So yes, it's definitely a good fit. But also remember that if it's above 0.8, it is good fit. If it's between 0.5 and 0.8, there is some correlation, but may not be the best fit or give you the best result for your equation. And then if the r squared is less than 0.5, there is not really a correlation. So in this case, we're going to say yes, the equation is a good fit, it's close to 1, and the data looks exponential decay. Okay, so according to the equation, what is the coffee temperature after an hour? So now we're going to use our equation to make a prediction. So temperature after an hour means we're talking about the x data. So they want us to input x data to find the y. And our x data is in minutes, so we have to convert 1 hour to minutes, so that would be 60 minutes, and then plug into our equation and see if it makes sense. So go ahead and do that. Put x equals 60 and plug in to our equation. And remember, this 0.988 is the only thing to the 60th power. So it's best in your calculator to do 0.988, carry it to the 60th, and then multiply that by the 171.462. So go ahead and pause the video and try that and come back. Okay, so you should have gotten 83.1 degrees Fahrenheit. And yes, this does make sense. 10 minutes later, it would most likely cool farther down, so it does make sense. Our second question, we can't do yet. I haven't taught you how to convert our exponential to logs yet. This is asking for the, giving you the y and asking for the x. So we can't do this yet. We'll have to see if there's time later in the unit. But our main thing is understanding how to get an equation, how to run it, and then plugging in to the values. So later when we go to solve equations, if they ask for the y, you'll solve it the way we're going to be learning how later in the week. So second question, it's asking of us to look at the average growth rates of 12 cherry trees planted in Washington, D.C., and they want you to determine the logarithmic regression model equation. So go ahead and pause the video and input your data and then bring it back. Okay, so once you've input the data, remember you want to look at your graph, and the stat plot should already be on from the last problem, but if it's not, you check that and then do zoom 9 for zoom stat. And wow, this does look like logarithmic function. So our cherry trees are growing at a natural logarithmic. Now, when we run our regression, we want to run it with the natural logarithmic because it's a natural growth. And so we're going to hit number 9. Do not use logistic in this unit. Always use, no matter what the logarithmic is, always use natural log. So the LN regression, number 9. So you're going to hit number 9 for the natural logarithmic regression and enter again. And here's our equation. Again, we're going to use 3 decimal places for A and 3 decimal places for B. And you can see this is a good fit equation. Our R squared is close to 1. So go ahead and pause the video and write that information in. Okay, so don't forget you're always going to use number 9 when they ask you to run the logarithmic regression. So the natural logarithmic regression. All right, for this first question, it's asking what the average height of the trees after a year and a half. And again, they're giving us the x values. We're going to plug in 1.5 a year and a half to find the y value. So try that and bring it back. When you plugged in 1.5 for the natural log, you should get 8.58 feet. And that does make sense. That value is in between 1 and 2, and it makes sense that it would grow faster in the first 6 months to me. Okay, we now want to study for the quiz, review for the quiz. Again, we're going to, this question's asking for y, so we're going to learn how to do that later in the unit. So I want you to go ahead and try these 2 problems and bring it back to see how you do. Okay, for this first one, you should have found the vertical asymptote to be x equals 3 and the horizontal be y equals 1. And then here for our behavior, we either use the graphing by hand or the calculator. You should have found that there were gaps at the asymptotes in the domain of -2 and 4, and this to be your answers for the other. Please see us if you need